Okay. Right, croissants away, please. Only 2 croissants and M&Ms. And pastries, pain au chocolat. Okay. So before you ask me, Reem, here's the name of the lesson. Histograms. So you have done histograms with column. The biology students have. No, I'll go get column to check. But yes, long ago. So what is? Hey, come on, listen. Beam. So what is a histogram? It has the bars. Yeah. So, is there or is there not spaces between the bars? No spaces. That's very important. Yeah. And what goes on the x-axis?
The year.
Well, give me the general. What goes on the x-axis? Yeah, which would be what? It would be like. Give me an example. What could it be? Not time. No, definitely not. No. It needs to be something which is continuous. Remember these words we did? Continuous, discrete. So continuous would be like a height, weight. What else do we have? Enzyme activity or something like this. So in other words, for the histograms, what goes on the x-axis is x, where x, I'll just write CTS for short, is continuous data. Yeah, continuous data. Like you said, heights, weights, enzyme activity, whatever. And then what goes on the y-axis here?
Discrete.
No. Yes, numbers go on both axes. But what numbers go on the y-axis?
Countries.
Well, why do people keep saying countries? What example did you possibly do with column that has countries on the y-axis? Come on, what goes on the y-axis? My goodness, Colin, I'm so angry at all of you. What goes on the y-axis? I'm talking in general rather than an example.
The data.
You're getting close. The amount, what's the amount called? The word that begins with F.
Frequency. Yes?
We're almost there. So, almost.
Oh, Jesus.
You just screamed it.
Did you miss the last class where we did the cumulative frequency curve?
No.
I think you missed the last class. Do you remember in the exam I said there'd be one person who'll do the graph wrong?
Yeah.
I was there.
You know it's not cumulative frequency. The reason it's not cumulative frequency is because that's the cumulative frequency graph. So anyways, I'll put you out of your misery. What goes on the y-axis here is frequency per x. And what I mean by that is, if for example, let's say x is height in centimeters or something like this. So you would have maybe here 150, here 151, here 152 centimeters. The height of this bar here, the height of the bar, is the frequency. So in other words, that's how many people are between the height of 150 and 151, divided by the length or the width the class width, the bin width, which is here going to be 1. So in fact, if you break your bars up into thickness of 1 unit, then the height and the frequency will be the same. But this will not happen, okay? So I'll give you an example now. So what you need to take from this is that the height is the frequency over the width. That's the formula for the heights of the bars. So let's take a frequency table here. Okay. So here's our X and here's our F. So let's say 1 to 3, 5 to 7, 9 to 11, 13 to 15, 17 to 19, 5, 10, 2, and 3. Okay, so I'll just give you a minute to write this table down. So I'm going to draw a histogram for this one here. You got that table? So when we were doing the cumulative frequency graph, we had to make a slight change to the table. We had to put in the upper bounds, and then what else do we need to put in? The cumulative frequency. So for example, the first number here would have been 5, and then what would the next number be? 10, and then the next one 20, and then 22, and then finally 25, okay? For drawing a histogram, you need to put the boundaries in as well, so I'll do that first. So here this would be 0.5 all the way up to 3.5, and then this is 3.5 to 7.5, 11.5, isn't it? Yeah. Sorry, did I skip something here? What? Oh yeah. Wait, you're right, I did.
I just want to pass on a message to Joseph.
Sure. Alright, I'll write those in again. So 1 to 3, and then this one here. Not, definitely not 3. 4. No, 5 to 7 is what I had last time. We skipped over a number. Now I won't make them the same lengths. I deliberately won't make them the same lengths. I just want to make sure they connect, okay? 4 to 7, and then this one, let's say 8 to 9. Yeah. Yeah. Make this one small. 10 to 15, and then 16 to 18 then. Okay, so now we'll put the boundaries in. Yeah. Yeah. Yeah, that's it, yeah. So the first boundary is 0.5, and then 3.5. Was that Curdy? 9.5, 15.5. Okay. Shh. Now, hey, come on. So there we go, there's all the boundaries. But for the histogram, you also need to write in what the class widths are. That's how wide they are. So the widths, these are the boundaries. Now these are the widths. So how wide is this one here? 3.5 minus 0.5. So that's 3 units. And this one here, 4, 2. This one here, I actually should put the last one in as well. 18.5. So 3 then. These are the widths. And now finally we can put in the heights. And the heights will equal, the formula is frequency divided by the width. So that's just going to be 5 divided by 3, so that's 1.66. 5 divided by 4, that's 1.25. 10 divided by 2, that's 5. 2 divided by 6, 0.33, and then 3 divided by 3, 1. This is the key for making the histogram, is these numbers here. So are you clear about how I got these numbers on the top? What are these called? The bounds. What's wrong? The width. It's 7.5 minus 3.5. Yeah, not the 7 minus 4. So they're the bounds. You understand how I got the widths, right?
Yes.
It's the upper minus the lower, and then the height is the frequency divided by the width. So it's the frequency, which is here, divided by the widths. That's the answer there.
Why did you add the last one, 18.5? It's just like that, right? But you didn't.
I need it for the graph. I need both the lower and the upper for the graph.
But you didn't use it for the height, right?
I did it. 18.5 minus 15.5, that's 3. It's the upper minus the lower. There it is there. Upper minus the lower. Yeah. Yeah, it's okay. Now, I need to scroll down. So do you have this table copied?
Yes.
Yeah, okay. So what was my smallest x value? Sorry, what was my first lower bound? 0.5. And the highest one? 18.5. So I think I'll go from 0 to 20 on the x-axis. That should cover all my numbers. So I have a 10 here, I have a 5 here, I have a 15 here, and then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now, what's the biggest height I have? No, height. I think is it 10? 5, is it? Alright, so I'll go up here. 1, 2, 3, 4, 5. Oh, by the way, guys, so you know for the histogram, you don't need these to match up. So you notice how my 0 here on the y-axis matches up with the 0 on the x. That's completely unnecessary for the histogram. You could have drawn this vertical line anywhere. So like I could have put it, you know, here at number 1 or here at number 2. It's not necessary for them to match up. Okay? Not necessary to match up. Alright, so where is the lower boundary for the first bin? It's 0.5, isn't it? So that would be here. And what's the upper boundary? For the first bin is 1, 2, 3.5, which is here. And what's the height of the first bin? So I'll draw it up here to 1.6, and that's it there. Okay, whoops, close enough. Now what's the next one? I'll draw that a little better. Now what's the next one? 3.5 up to 7.5, and what's the height? 1.25. So that's a little bit lower. Okay, the next one? It's 7.5 to... Oh, so it's quite small. And the height?
5.
Okay, the next one then?
Is 9.5 to 2.5.
Yeah.
And then the height is 0.3.
0. And then the final one is up to 18.5. So that's here.
And the height is 1.
Now let's see the use here, the histogram. So how big is this rectangle here, its base? It's from 0.5 to 4.5. So how many units here? It's 3 units. Yes, and what's the height? It's 1.6. So if you take out your calculator and multiply, let's get the area. So what's the area of this one here? It's 1.66 multiplied by 3. What's that? Type it in. What is it? So round it off to 5 then, yeah? Okay, how big is this base here? It's 3 units and the height is 1.25, isn't it? It's 4 units, sorry, and the height is 1.25. So what's the area of this one here? 5. 5 no, I think we typed it in wrong. It's 4 multiply 1.25. Now, the area of this one here will be 10. And the area of this one here, you notice what's happening is each of these areas are the frequency. So what was the next frequency in your table? 2. And then the last one? 3. So the important thing you need to know for the histogram is that the area equals the frequency. Not the heights, but the area. But please note, if I made each bar have a thickness of 1 unit, then in that special case the area and the heights will be the same. Because what you'd be doing is the area, what's the formula for area? Is base multiply height, right? Basic maths. But if the base is 1, then you see the area and the height will be the same. That's what most people do when they draw a histogram. They make the units 1, but that's not always possible to do. So the most important thing to know is the area gives you the frequency. And why is that useful? So for example, I could now answer the question, how many people, if this was, I don't know, heights or income or games or whatever, how much is between 6 and 9? So if I go back to my table, do I have any bin that's between 6 and 9? No, I don't, do I? But if I go to this table here, what I could do is find the 6, here it is here, find the 9, here it is here, and I could measure this area. And this area here, as an example, would be the frequency for between 6 and 9. So that's why the histogram is useful, because once you have it as a histogram, you can find the frequency between any 2 numbers. But there's something missing from my histogram. I didn't put in the names of the axes. So what goes on the x-axis here? Well, that would just be the data x. And then on the y-axis, it is the frequency per unit x. So this is the other type of graph you could be asked to draw. There's 2 graphs in the statistics question in the exam. You can be asked to draw a cumulative frequency polygon, or you could be asked to draw a histogram. Okay. Let me see. Oh yeah, a little bit of vocabulary. What was the definition of mode average? Yeah, very good. The highest frequency. Remember mean, median, mode? So in this histogram, what is the modal bar, which is the biggest bar? Well, you can see it in the middle there, it's the 10. So what answer would you say? You would go in the middle if you wanted to give it as one single number. You would choose the middle here. So that's 9.5, and what was that? 7.5. So you could take the middle there. Or you could just say, you could say the start and the end. So you could give the answer as the mode would equal, what's that going to be? 7.5. What's this? 7.5 plus 9.5 over 2. That's 8.5. So the mode here is 8.5. Yeah. So The cumulative frequency curve, what does that give you? That tells you the lower quartile. What else? Upper quartile, interquartile range, and the median. Whereas the histogram, that tells you the mode. And if you want the mean, that's just using the frequency table. There's no need for a graph. So the histogram can give you the mode, the cumulative frequency can give you the median. Yes, Sadiq?
So it acts like the total area of the histogram or something like that. Is it the highest?
No, the total area of the histogram is the same as the total frequency. Yeah. Put it away.
That's what
Is it water?
medicine.
It's medicine, oh yeah.
I still don't get
That is a statement. I'm saying the histogram. I showed you how to make it, and my point is, if you make the histogram like I've shown you here, the result is the area will always be the frequency. So if I said to you, what is the frequency between 0 and 4, for example, or between 1 and 4, you draw in the box between 1 and 4, which is here, and you measure that area. That is how much you have between 1 and 4. That's the frequency between 1 and 4. Yes?
Why did you draw the nice bar at the start?
Why did I do what now?
Yeah. Draw the nice bar on the device at the start.
Why not? This isn't a bar. This is an axis.
Yeah. And the scale?
There's a scale, just to know if I have enough space to draw it on my paper. Yeah, because I need to put the biggest ones in first on the axis to know if I'll have enough space when I draw it. You really don't like doing graphs. Same for you. No one likes graphs. Nonsense. Yeah. Yes. But you said you did statistics in Libya, right?
Yes.
Weren't you drawing graphs all the time?
No, most of
Bored.
What?
Bored.
You're bored of graphs. Mostly doing what?
Mostly doing like, they give you like number of the people who have this disease and like, this kind of stuff. I don't know what's,
Probability.
yeah.
Ah, yes, that is different. Yes, yes. So no graphs. Not many. Okay, interesting. Interesting. Okay.
So I think most of the statistics that we have, like, they give you a rule and you just follow